Today's lesson is on interpreting graphs, and we're going to use this time to go over the key components of linear functions on the graph, and also to kind of give us a little bit of a cheat sheet or a guide for somewhere that we can go to confirm different components of the graph in case we forget. So on your outside tabs, you're going to quickly jot down the following categories on your foldables. So the first category is X and Y intercepts. The second is increasing and decreasing intervals. The third is relative maximum and minimum. And the fourth is zeros, roots, solutions, and X-intercepts. Those are all the same thing. There's just different words for that concept specifically. So this is one big chunk of information right here. Once you're set with those titles, you're going to open up all the tabs on your foldable. And just double check on the inside that your graph is right side up. I personally put my graph in upside down first, and then I made a mistake and I had to do it over again. So remember, your negative values are on the bottom and to the left, and your positive values are to the right and on the top. So just double check your axes. Make sure you pasted your graph in right side up before we start. Okay? The other thing you are going to want to have are several colored pencils, pens, etc. I would recommend 1, 2, 3, 4, 5, 6, at least 7 colors. I know that seems like a lot, but this is really going to help you to identify the components of the graph that you want to work on. Okay? So if you need a minute, pause, get your materials, and then come back. The first thing we're going to talk about is the X and Y intercept, and remember that's in the upper left-hand tablet. So the X-intercept is the point at which the graph crosses the x-axis, right? That makes the most sense. That when you're intercepting x, that's when you cross the x-axis. At this point, y is equal to 0. Because when you think about your coordinate points, if you're actually on the x-axis, then you haven't gone up or down. You haven't gone any direction vertically, any value. So you're still on 0 for y. So the y-intercept would be the opposite of the x-intercept, right? The y-intercept is the point at which the graph crosses the x-axis. I'm sorry, the y-axis. And this is where x equals 0. So again, this is one of those things that it's pretty intuitive when you actually think it through. If you're intercepting the x-axis, then you're crossing the x-axis and y equals 0. If you're intercepting the y-axis, then you're crossing the y-axis and x equals 0. Here's where your colors are going to come in. You're welcome to use the same colors that I am. You're also welcome to use different colors, but try to stay consistent with regard to what you're circling. So for example, the x-intercept. I'm going to use red to highlight the x-intercept, and then I'm going to look at my graph and I'm going to find the x-intercepts. There are more than one, right? So first of all, if I start from the left, I'm looking at where my function is crossing the x-axis, and I see that here at -3. Then I follow the line of my graph, and I see that it crosses the x-axis again at +1, and one more time at +5. Right? Is it clear? Hopefully it's clear that those locations are x-intercepts. The y-intercept, I'm going to use green. Whoops. So if you don't know, my favorite color is purple. So the green marker on my smartboard automatically writes in purple unless I change it. Just a fun fact. So if I need the y-intercept in green, not purple, I'm going to look at my function. I'm going to trace the line all the way until I see it cross that y-axis. and I'm going to mark that point at positive 2. Note that if I actually wrote the coordinate points for any of these, so the y-intercept point is at 0, 2. And remember how I said x would be 0 at the y-intercept? And then all my x-intercepts, the first one is negative 3, 0. The second one is 1, 0. And the third one is 5, 0. And again, I said that y would be 0 at all those points, which it is. The next section we're going to look at is right underneath. It's increasing and decreasing intervals. So we're going to jot this down quickly. A function is increasing on an interval if the y value increases as the x value increases. Now save some room because we do want to do decreasing intervals as well. So I'm just going to use a little smartboard magic here. There we go. So a function is increasing on an interval. When I look at the concept for increasing, I am going to use the color pink. And I'm going to underline that increasing idea. And it increases when the y value increases as the x value increases. So think about this. If I was starting over here, and I'm looking for when y is increasing and x is increasing. Well, at this point, y is negative 7. So if I move up to the right, y moves to about negative 3. And going back to my original point, my x value is negative 6, and it's going up to negative 4. Remember, getting closer to 0 is increasing if you're starting in negative numbers. So this increasing pattern continues all the way up this slope of the function, right? And you can always see a function increasing because it's also a positive slope, right? A positive slope goes from left to right and it slants upwards. So where else on my graph is increasing? If I start at this low point here, I'm also increasing as I follow the graph upwards. So hopefully that's pretty straightforward. It's more of an observation. If you really need to look at the fact that the x is increasing, the y value is increasing while the x value is increasing, that is perfectly fine. If not, and you can just see it, that's great too. So I'm just copying that statement again because I just want to say that if a function is decreasing on an interval, it's if the y value is, this is the opposite now, right? If the y value decreases as the x value increases. So I'm looking at the fact that my y value is decreasing, whoops, as my x value is increasing. And for this area, I'm going to use kind of a yellowy green, if I can. There we go. So a function's decreasing. And obviously the area that's decreasing is when the y value is decreasing while the x value is increasing, right? So from left to right, you're slanting downwards. Again, these ideas are more observational, but just, to give you a reminder of slope. Also, increasing functions always have a positive slope. I think I did say this. And decreasing always have a negative slope. So if you remember, slope is rise over run, right? So if, because that's division, if either one of the numerator or the denominator is negative, then it's decreasing, it's a negative slope. If both of them are negative, then it's actually increasing. So you just kind of have to think about the way that your fractions will work as kind of a memory trick. Moving on, the upper right-hand corner of your foldable, we're going to talk about the relative maximum. So the relative maximum is the y value of the highest point in a particular region. So again, I don't know if you've noticed, the increasing and decreasing concepts talk about intervals within a certain interval. Again, the relative maximum and the relative minimum will talk about the highest point or the lowest point in a particular region of the graph. So the relative minimum is the y value of the lowest point in a particular region. And that's because linear functions and also some nonlinear functions will go on for infinity. So we do specifically say we're looking at a particular region of the graph because that may not be the only maximum that you're going to see on the entire graph. If you zoomed out on your calculator for a really long time, you might find yourself another maximum, right, or another minimum. So in this particular graph, the relative maximum in the region that we're looking at, because this graph goes up and off with an arrow and down and off with an arrow, we're assuming that we're not looking at those points because they go off into infinity, right? So the relative maximum is the highest point, which is right up here, and the y value is 4. So y equals 4, and that's the maximum. And then the relative minimum is the lowest point on the graph right here, which is actually the minimum is y equals -4, right? So again, we're looking at a particular region of the graph, which is why we're not kind of circling those really high arrows or those really low arrows. The very last section of your foldable is the x-intercepts. The zeros, the roots, and solutions. And again, this is all the same thing. An x-intercept, a zero, a root, and a solution, those are all the same exact thing. They are all names that describe the x value of a function when the y value is equal to 0. So whose corresponding y value equals 0. So what does that mean? We already know what an x-intercept is. It's the point at which the graph crosses the x-axis and y equals 0. So all of these things, the x-intercept, the zero, the roots, and the solutions, are where the function crosses the x-intercept and y is equal to 0. These are all solutions to the equations. They're also referred to as roots, as zeros, right? It makes the most sense. When y is 0, this is where we're talking about. And when you think about a graph, when you think about the basic form of a function that you know, which is y equals mx plus b, that function notation really allows you to imagine, well, if y was equal to 0, that helps me to think what would be the answer to the actual function.